Oh, good day. So we are the group one. So our course is MTEC 102, period midterm, week 2, session 2, and the topic for our video reporting is the parts of the sextant, errors of sextant, and how to correct the errors of a sextant. So the course outcome is to know the parts of sextant, the errors of the sextant, and how to correct the errors of a sextant. Learning outcome. So at the end of the session, the student shall be able to know on how to correct the errors while using sextant and know the parts of a sextant. So importance of the topic. So sextant is a traditional navigational tool. It measures the angle between two objects such as the horizon and a celestial object such as a star or planet. So this angle can then be used to calculate the ship position on a nautical chart. So our first topic is parts of a sextant. So we have here the image and the labels of the names of the parts of the sextant. So the parts of the sextant. So first is the frame. So this is either a rigid metal construction or molded plastic. It incorporates three legs upon which the sextant rests. When in the horizontal position, the upper side of the frame is referred to as the plane of the instrument. So the curved lower part of the frame is referred to as the lower limb of the instrument. Next is the handle. So the handle is fitted with a button switch and has a compartment of four batteries to power the electric light on the index arm. So next is the telescope or monocle. So this is used to enlarge the observed object and to make accurate and observations easier. The telescope usually has a magnification of four times and a field of view of 5 degrees. The monocle, on the other hand, has a magnification of 6 times and a field of view of 8.5 degrees. So higher magnification is desirable when observing vertical sextant angles of distant shore objects to obtain a clearer view of the sun's lower limb when taking sights. So a wide field of view is important when trying to locate stars which are not easily found because of the apparent size. Next is the rising piece. So the telescope or monocle is attached to the frame by an adjustable slide or rising piece, which is fitted with milled head quick release screw. By adjusting the rising piece, the telescope is brought closer to or farther from the frame. This adjustment alters the area of the horizon mirror viewed through the telescope and hence alters the brilliance of the reflected image. Next is the arc. So if the sextant is of the metal variety, the arc will be constructed of a thin strip of metal which has a low coefficient of expansion. It is let in flush with the lower limb of the sextant and is graduated from 0 degrees to 120 degrees on the arc and from 0 degrees to negative 5 degrees of the arc. Next part is the index arm. So the index arm is mounted on a circular base plate and is free to rotate on a central axis underneath the index mirror. So the arrow of the index arm is known as the index mark. So next part is the clamp. So by exerting finger pressure, the clamp disengages or unclamps the index arm from the gearing cut into the lower limb of the sextant. So the index arm can then be moved to the required angle. On releasing pressure, the index arm is automatically clamped in position. Next part is the worm and rock. So the worm is an endless tangent screw which engage with the rock or gearing which is cut into the lower limb of the sextant. So exerting pressure on the quick release clamp disengages the worm from the rock and allows the index arm to be moved. So next part is the micrometer drum. So while whole degrees are read directly from the arc, minutes of arc are read from the micrometer drum. Turning the micrometer drum screws the worm along the rock and permits fine adjustment of an observed angle or altitude. Next part is the micrometer vernier. So the micrometer vernier has 5 or 6 graduation which corresponds to 0.2 minutes of 10 minutes of arc respectively. So minutes of arc are read off the micrometer drum opposite the vernier index mark. So seconds or decimals of a minute of arc are read where one of the vernier graduations lines up perfectly with one of the minute graduations of the micrometer drum. So the next slide will be discussed by Cadet Aligado.
Parts of sextant. Then the electric light. The light bulb is contained in a special holder, so arranged the light illuminates the arc. Micrometer drum and vernier. It is operated by pressing the buttons in the handle and is useful for taking twilight sights. Index mirror. The index mirror is rectangular in shape and set in a frame attached to the index arm. Its purpose is to reflect light to the horizon mirror. Its purpose is to reflect light to the horizon mirror. The index mirror, the index mirror clips. These are spring clips that hold the mirror to its frame. Index mirror adjustment screw. First adjustment. This is an adjustment screw situated on the century line of the mirror. By adjusting the screw, the mirror is pushed against the spring clips and moved to the perpendicular position. The index mirror shades. These shades are made for high quality optical glass and are neutral or colored light filters. These are used to reduce intensity of the sun's reflected image and protect the eyes. There are normally four shades. Next slide, please. The horizon mirror. This mirror receives the image from the index mirror and reflects it back to the observer through the telescope. It can either be rectangular or circular mirror held in the appropriate frame, as the horizon mirror occupies the only half space enclosed by its frame. The observer is able to see both re- reflected image and horizon at the same time. Like the index mirror, it needs to be perpendicular to the plane of the instrument and parallel to the index mirror when the index arm is set to 0. The horizon mirror clips. The, these clips hold the horizon mirror in its frame. The horizon mirror adjustment screw. Second adjustment. This adjustment screw is situated on century line of the horizon mirror. It may be on the top or bottom of the mirror, depending on its design. It is used to adjust the horizon mirror to the perpendicular position. Horizon mirror adjustment screw. Third adjustment. The adjustment screw is located on the edge of the mirror and is used to adjust the horizon mirror parallel to the index mirror when the index arm is set to 0. The horizon mirror shades. These are used to reduce the intensity of the brightly lit horizon and are similar to the index mirror shades. Two or three horizontal shades are normally fitted. Errors of sextant. Adjustable errors. Perpendicularly error. This error appears when the index mirror, rectangular mirror, is not perpendicular to the frame and arc. It is easy to detect it. Put sextants on a horizontal plane and move alidade to the position 35 degrees to 45 degrees. Look at the index mirror in the direction of the arc graduated scale. We see two images of the scale. The reflected image on the left side, the direct image on the right side. We must see straight line. The arc with the graduated scale is in the photo. If we see broken line, we remove the error using the adjusting screw on the index mirror. Side error. This error appears when the right horizon mirror or rounded mirror is not used perpendicular to the frame. We choose a very small star in the sky, less than magnitude 4.0 or 5.0. To identify the error, set the alidade to 0 degrees. Observe the star with the sextant and move drum, minute scale. The reflected star has to pass alternately below and above the direct star, not reflected. Here, here the reflected star does not pass on the direct star in a vertical movement. The side error must be removed using adjusting screw on the horizon mirror, screw number 1, and the next reporter would be Cadet Azeo.
Error of sextant. Adjustable error. Collimation error. The error of collimation is due to axis of the telescope not being parallel to plane of the instrument. A high quality sextant is not affected by this error. So this is the collimation error. Slide please. Adjustable error. Index error. We can use the C horizon of small star, the sun of horizontal line at a just of 3 nautical miles at least to avoid the parallel parallax error. The sextant has an index error if the index mirror and horizon mirror are not parallel when the index arm and the drum width minus scale are set exactly at 0. If the error is more than plus or negative 3.0, we have to reduce it. Next. Index error. We move the drum until we see a straight line. The reading is the index error. We can use the sun to detect this error with 2, 4, 6 measurement. Non-adjustable error. Graduation error is due to the inaccurate graduation of the main scale or of the micrometry Werner. Non-adjustable error. Shade error is due to the two surfaces of the colored shades not being exactly parallel to each other. Centering error is a cause of due to the pivot of the index bar not being coincident with the center of this circle of which the arc is part. Optical error may be caused by prismatic error of the mirror of the or aberration in the telescope lines, where on the rock and worm, which worm forms the micrometry movement, would cause a blacklist, leading to inconsistent error. Next, please. Next slide. How to correct error adjustment screws. Even if sextant is equipped with error adjustment screw, the design of this screw varies from sextant to sextant. Some have ordinary screw drive slot, while others have round heads with a hole drilled through it. The first required the use of the suitable screw drives. The other required the use of a special pin insert into the hole. In order to make an adjustment, the screw should be adjusted gently clockwise or anti-clockwise to avoid cracking the mirror. One must remember that the sextant is precision instrument and any adjustment must be made delicately. Next, how to correct error. Perpendicular error. The index mirror must be perpendicular to the plane of the instrument. If not, then particularly error is present. First adjustment. Within the telescope molecule, remove the shades, turn away from the mirror, and the index arm set the middle of the arc. Carry out the following. Take the adjustment pin from the sextant case. Insert the pin in a hole in the index mirror adjustment screw. Using the gentle pressure, turn the adjustment screw until the true and reflect arcs appear in the straight line. Remove the pin carefully to avoid upsetting the, the adjustment and the replace in, in the sextant's case. Perpendicularity error has been removed. Next. Next reporter is Bation.
So I'm Cadet Batayon. How to correct errors. Side error. The horizon mirror must be perpendicular to the plane of the instrument. If it is not, then side error is present. Horizon method. Remove the telescope or monocle and swing all shades away from the mirrors. 2. Set the index arm and the micrometer drum to 0. 3. Hold the sextant horizontally and look through the horizon mirror at the horizon. 4. If the true and reflected horizon appears in a straight line, then there is no side error present. 5. If the true and reflected horizons are not in straight line, then side error is present and needs to be removed. Next slide, please. So, side error. The horizon mirror must be perpendicular to the plane of the instrument. If it is not, then side mirror is present. So, the second adjustment or the horizon method. With the telescope monocle removed and the shades turned away from the mirrors, carry out the following. 1. Remembering that there are 2 adjustment screws on the horizon mirror. Identify the second adjustment screw. This is on the side of the horizon mirror. Remove the adjustment pin from the sextant case and insert it in the hole drilled through the second adjustment screw. Hold the sextant in the horizontal position and look through the horizon mirror at the horizon. Then gently turn the adjustment screw until the true and reflected horizons appear in a straight line. Then remove the pin carefully to avoid upsetting the adjustment and return it to the sextant case. And lastly, side error has now been removed. Next slide, please. So this is the example of the side error. So index error. When the index arm is at 0, the index arm mirror and the horizon mirror will be parallel. If they are not parallel, then index error is present. Third adjustment. With the telescope or monocle fitted and the shades moved away from the mirrors, carry out the following. 1. Set both the index arm and the micrometer drum exactly to 0. Then locate the third adjustment screw on the horizon mirror. They are usually at the top of the mirror. Then remove the adjustment pin from the sextant case and carefully insert it in the third adjustment screw. Then hold the sextant in the vertical position. Then look directly at the horizon or star. Then adjust the horizon mirror until the true and reflected image are in straight line. Then carefully remove the adjustment pin and replace in the sextant case. And lastly, the sextant should now be free of index error. Next slide, please. So, residual index error. In order to reduce the possibility of the adjustment screws becoming loose with usage, It is recommended that a thorough check and adjustments of the sextant be carried out periodically but not too often. Usually, only the residual index error needs checking, and any error found applied as a small correction to the navigator's observed altitudes and angles. The residual index error is checked each time the sextant is used and before an observation is taken. So examples of sextant reading adjustments or residual index error. Example number 1. Before taking a sextant altitude of the sun, the sextant was checked and found to have an index error of 2.2 minutes on the arc. After taking the sun sight, the sextant altitude recorded was 24 degree and 19.5 minutes. Determine the observed altitude of the sun. So sextant altitude is equal to 24 degree, 19.5 minutes, and the index error is negative 2.2 minutes. So the observed altitude is 24 degree and 17.3 minutes. Next slide, please. So example number 2. The sextant's index error was found to be 1.9 minutes of the arc, whilst the vertical sextant angle of an object ashore was 2 degrees 34.5 minutes. Find the vertical angle corrected for the index error. So the vertical sextant angle is 2 degrees and 34.5 minutes, and the index error is 1.9 minutes. So the observed angle is 2 degrees and 36.4 minutes. Next slide, please. So that is all, and thank you for watching.